Alright, so good morning folks, or good afternoon, or good day. Good day to y'all. So what we're going to do today is we're going to look at the unit circle and we're going to be completing some theorems regarding angles and their trigonometric functions, relationships. So we're going to be looking at the unit circle and its position on the coordinate plane to figure out how those relationships will be affected. We've got a few theorems we're going to go through. I'm going to try to make a little video for each separate theorem. So the first theorem we're going to look at, well, I guess it just depends on which one you view first. So the homework is page 240, 1 to 16 all. And so let's just jump right in. So this first theorem is called the Pythagorean Identity. Okay, so let's think about that for a hot minute. So the Pythagorean Identity, if you think about the Pythagorean theorem, which is what it stems from, the Pythagorean theorem is all about right triangles, true? So when we're talking about right triangles, what we're talking about for the Pythagorean theorem is the fact that a squared plus b squared equals c squared. And what we're talking about that in light of a right triangle. So what I'm going to do is I'm going to come over here and I'm going to go to my grid and I'm going to draw me a right triangle. I know that's not a right triangle. Okay, so I'm just going to come up here and I'm going to edit my points. I'm going to bring my over there. I'm going to make this down so that it might be a right triangle. I'm going to move that, I'm going to move that so it's pretty. So you can see that in fact this is a right triangle, and boom. And there's my right triangle. Okay? So in the right triangle we're told that a squared, which is one leg, plus the other leg squared equals c squared. Well, what we've done is we've taken this right triangle and we've put it inside of a unit circle. So if it's inside of the unit circle, what do we know about the length of this? Well, that's our radius. So since that's our radius, we got that that's our radius. So now we know a squared plus b squared equals r squared. Well, if I'm looking at this ordered pair here, that means that this ordered pair, right, would be AB. Well, I don't want to use A and B because I want to use my Pythagorean theorem, and I want to use the fact that it's inside the unit circle. So this horizontal distance is x. And this vertical distance is y. So now my A is really x, my B is really y, and my C is really r. So I've got x squared plus y squared equals r squared. But this is on the unit circle. So since this is on the unit circle, what is the radius? Well, the radius is 1. And how do I calculate x on the unit circle? Because this ordered pair right here is the rotation of 1, 0, right? This angle. So what we learned last class is that this ordered pair is cosine theta, sine theta. That's our rotation of the point around the center, which is the origin. So that means that you must remember this. Cosine theta equals x, and sine theta is y. The fundamental things of trig, the unit circle, which means that since this is the ordered pair xy, we can replace x with cosine and we can replace y with sine. So our formula for the Pythagorean identity is cosine squared theta plus sine squared theta equals 1. That makes sense, right? Which also means we could solve this for other variations. So we could have sine squared theta equals 1 minus cosine squared, if we subtracted cosine from both sides, true? Or we could have cosine squared theta equals 1 minus sine squared theta. And it's just different ways to find the various lengths of various triangles, or the various angles. Okay? So that's the first one, which is our Pythagorean identity.